In this video, we're going to sketch a couple square root functions as well as a cube root function. We'll identify the domain and range. I'll show you some tricks on how to do that. I'll also show you how to plot a couple extra points on both of the functions. So when it comes to sketching square root functions, the first thing you're going to want to do is identify the starting point. And I've got my formula right here that you could use. However, a trick is you can put parentheses around those two values and then a comma right there, and you could pull that starting point from your equation by changing the sign of that first value. So since it looks like we're subtracting 2, it's going to be a positive 2, and then we're going to keep the sign of the following one. So then when we graph, that'll be the starting point. So I'll go ahead and put that on the coordinate system. It's going to be 2, -4, and that's what we start with. Okay, now the next step is finding another point that we could graph using the equation. So I'm going to look at that value in front. This is the a value, right? Whatever's in front of that radical will represent the a, and I always move to the right 1. And because that value of a is 3, I'm going to go up 1. So I'm going to have to go over 1 point, and then I'm going to go up 1. So over 1 and then up 1, 2, over 1 and then up 3, right? Because that a value is 3. So I'll go ahead and plot that point. And that point will then be 3, -1. So that's going to be a second point. And that allows us to see how that square root function looks. It's a little bit more accurate, I guess, way of putting it down. And it's going to go off to the right. And you're going to have a vertical stretch by a scale factor of 3. Because you are vertically stretching that function. It's kind of like getting pulled up and down like that. Okay, so got a good sketch there. Let's come up with the domain and range while we're at it. So I think of it as like for my range, I look at my left side and my right side, what's my lower boundary and upper boundary. So the lowest that goes is this 2 right there, and it's included in my graph. So I'm going to put brackets. And then the right side, we're going on to positive infinity forever. And then we always use parentheses with infinity symbol. And then for the range, we're looking at our lower boundary. I call that the floor. And then to our upper boundary, which I call my ceiling. So the floor here is -4. Okay, we bottom out at -4, and that is a part of our range. And then we go up forever. There's no ceiling, so that's going to be a positive infinity. Now let me backtrack a little bit. Let's just say that you have a hard time finding that second value right there, right? You don't know anything about that 3, you don't know how it affects it, you just want to get another point to help you graph this curve. So what you can do is pick a x value in this domain that we just figured out, evaluate the function for it, and that'll kick out the y value that'll be a part of the range, and you can just plot that point on your graph. So what I did right here is just set up my function, and I'm evaluating it for 10. So I'm going to replace the x's with 10. That's my input. And then you can evaluate, you do the math, and that'll kick you out the output. That'll be the y value that goes with that x. So in this case, if you plug in the 10, it'll be approximately 4.5 for the y. And then you could graph that point on your coordinate system too. That would be somewhere up in this range. That would be 10, 4.5. Of course, you'd want to put the other tick marks in that, make it nice and accurate. But that would be another way to graph a second point, just by picking any x value in this domain here, and then evaluate the function, and that would get you your y value that goes with the x value, and hence another point. Okay, in question 2, we have g of x. It's another square root function, so we're going to start by identifying that starting point. I'm going to put my parentheses in here. And again, we'll go opposite sign of whatever's underneath the radical, so that +3 ends up being a -3. And then I don't see anything out here. There's no number, so we could treat that as a 0. So I'm going to graph that on my coordinate system, which means it's going to be right here. It's -3, 0. And now we have to graph that second point. And I'm going to use my a value, which is a -1/2. And because it's negative, we know that that square root function is going to be flipped. So instead of going like a starting point and then over and up like that, we're going to have a starting point and it's going to go down and over like that one. And because it's 1/2, we're going to go over to the right 1 and then down just a half. So instead of going over 1 and then down a full point, just a half, because that value is a half right there. So then this point would be, it looks like it's going to be a -2 and then comma negative just 0.5. And we call that a vertical compression. I'll talk about that in a second. Let me go ahead and add in that like that. And then you could see, like, based on if we had a normal square root function, it'd be probably coming something like that, right? I'm just estimating. And then that orange one, because it's a value between 0 and 1, it's going to be vertically compressed. It's going to be squished together up and down. So anytime we have a value in front, right here, that a value is between 0 and 1, just like I wrote down here, you're going to have a vertical compression. It's going to get squished, like I just said. But if you have a value that is greater than 1, like the previous example, if a is greater than 1, it's going to be a vertical stretch. Okay, now we could get the domain and range. And again, back to the previous problem, I look at the domain is the walls. I need my lower boundary and my upper boundary. So my lower boundary right here gets as low as -3, but it doesn't get past that. And we include -3, so I'm going to use the brackets. And then the right boundary, the right wall, or upper boundary, is positive infinity, because this graph or the sketch is going to continue on forever in the right direction. So that's going to be positive infinity. Now, the range is a little trickier. We're still looking for the lower boundary and the upper boundary, but I'm going to treat this as this one right here that I'm squiggling. That's going to be your floor. That's your lowest part. And you can see, again, this graph, it's going down into the right forever. So it's going to be going towards negative infinity. There is no floor. It doesn't bottom out. It just goes down forever. However, when you look at the upper boundary right here, it does have a ceiling. And that's going, it's not going to get higher than this y value right there. That's the x-axis. That's the ceiling right there. So the top or upper boundary is going to be 0, and that is included in our graph because you got that solid dot. That was the starting point of -3, 0. So there you have the domain and range for a square root function when it's being flipped because of that negative in front. And a cube root function is a little bit different in the sense that you don't have a starting point. The middle point of that function would be called the point of inflection, or the inflection point. So we're going to still get that the same way. I'm going to put my parentheses around here, okay, and then I'm going to put a comma in between, but I don't have a value being added or subtracted from x, so then we treat that as 0. If you don't see a value being added or subtracted, you use 0, and then comma 2, because it was +2, and I can plot that on my graph. So it goes 0, and then we just shift up 2, and like I said, that's my point of inflection, or my inflection point. And then I look to my my front of my radical, and the a value right here is invisible 1. So scale factor, you'd say, is just 1, I suppose. But again, as always, we move to the right 1, and then if it's 1, we go right 1 and then up 1. So right 1 and then up 1. That'll be right about there. And that point then will be 1, 3, which represents the second point that I would want to graph. And then if I'm going to go ahead and graph this, I'm going to go up and then over, and it's going to go up to infinity over on that side. Now, the difference between a square root function and a cube root function is the fact that the cube root function has a tail. So it's gonna come back this way somehow. Oops, sorry. But to make it accurate, I'm going to try to do one more point, and it's just going to go back the same way. So instead of going forward 1 and then up 1, we're just going to go back 1 and then down 1. So that is going to be back 1 and then down 1. Point will be right there. And I'll go ahead and add in that tail. It's going backwards. So then this point right here will be -1, 1. So I got 2 extra points beside that point of inflection, which represents the middle of that. square root function, or I'm sorry, cube root function. And last but not least, we want the domain and range. So this one's a little bit easier. I have my left wall and my right wall, my lower and upper boundaries, but we continue on forever in both directions. So this one is actually all real numbers. And then the range, my lower boundary and upper boundary, I look for my floor and my ceiling, is also going to be all real numbers because there's no asymptote. Remember, this just goes down and to the left forever, and then it goes to the right and up forever. So the range is also all real numbers. And that's what happens every single time you have a cube root function. We're just going in each direction on to infinity or negative infinity. So that covers both square root functions, cube root functions, key features, and yeah, hopefully that helps.